Hello everyone, welcome to this session. In this today's video lecture, we are starting a new unit number 6, that is actually and eccentrically loaded columns. And this is the first video. So in this video, we will discuss or there is an introduction about the actually loaded column. We will see in this particular video. Uh, Axially loaded columns, or we can say the axial forces or axial compressions are there in a different members that we are going to study in this video or in this particular unit. There are actually axial loads, means there is a compression type of the loads are acting most of the time actually in the different structures whenever we are talking about the columns. And also strut is also a member that it incline and horizontal type of the stresses, or we can say the loads are acting onto that strut also. Means there are actually two types of compression member. One is the structural member of column, and also structural member of struts, that is also subjected to compression type of the members, right? So we will see, let us first slide. Introduction. Basically, structures, machines may fail in a variety of ways depending upon the materials, kinds of loads, conditions of the supports. So these failures are avoided by designing a member so that their maximum stresses remain within tolerable limits. Structural member subjected to axial compressive force is called as struts. So from this, as we know that the axial compressive force are subjected to strut is also a structural member, and also it is subjected to columns also, because in our building frame structures or also other type of the structure like bridges, that is column, it's one type of the member which subjected to compressive type of the forces or compressive type of loadings. Okay, and various factors which our structures are failed by different kinds of materials kinds of loads, and also the various conditions are also there which contributed for the failures of the structures or failures of the members. It has been experienced that sometimes compression member does not fails entirely by crushing. So already we know that compression members are or fails either by crushing or by bending. Okay. So bending is also called as a buckling. So there is a new word is coming in this unit, that is bending, buckling. Okay. So if it is our member is subjected to bending, at that time sometimes it is called as buckling or bending. Whenever there is a vertical member is bent, at that time it probably it is called as buckling of that particular vertical members. So this mainly happens in the long columns. Okay. So there is a bending or there is buckling, it is happen mainly in the long columns. And one thing important, that total compression member not 100% it is failed by crushing, but it also fails by buckling or bending. So column is a vertical structural member, as you know, that means that is a orientation of that column is vertical, orientation of the strut is vertical, and it carries the axial compressive load. So always you remember that columns or strut are taking axial or carrying axial compressive loads, and it is usually as long compared to the cross section. Means as compared to the lateral dimension, the length or longitudinal direction, it is long compared to its lateral dimensions. Next, strut. So what is meant by strut? Because basically in this unit we are detailed analysis of the strut and compression members are there. Definitely we will solve some of the numericals basically for the structural member, strut and column. So what is meant by strut? A strut member or structural member carrying an axial compressive load. So as we know that column and struts are taking axial compressive loads. It is a member of truss actually. This strut member is used in the construction of trusses. In the many factory on industrial sheds, that trusses we have to construct, and in the trusses, the one of the member is strut. It is usually short in length as compared to the column. The length of the strut is short. It may be horizontal or inclined, fixed rigidly or pin jointed at one or both the ends. Okay, so means support conditions are there. Maybe both the ends are fixed, maybe both the ends are rigid, or pin jointed or hinge jointed, maybe both the ends. Column is a long vertical slender bar or a vertical member subjected to axial compressive load. As we know that column is a long as compared to the strut, is a vertical member and it's subjected to compressive load. And also, as like a strut, it is fixed rigidly at both the ends. So failure of the column or strut, it has been observed that when a column or strut is subjected to some compressive force, then compressive stress is induced. So as we know that whenever there are loads, either tensile or compressive loads are acting on any member, it is induces or it will offer some resistance. Okay, so though our column is a compressive member, definitely there are compressive forces or compressive loads are acting onto the column, and because of this, it offers the resistance in terms of compressive stresses. So that's why compressive stresses are induced. So how to determine the compressive stresses? So sigma, as we know that P upon A. P is the compressive force acting on the column, and capital A is the cross-sectional area of the column. Okay, so from that you can determine compressive stresses induced in the column. Next, so this is a little bit descriptive description of the axially loaded columns, or we can say the strut. A little consideration will show that if the force or load is gradually increased, the column will reach a stage when it will subject to ultimate crushing stress, and beyond this stage the column will fail by crushing. So there at the ultimate crushing stress, the column will fail by the crushing or by the buckling also. The load corresponding to crushing stress is called as the crushing load. Okay, so means ultimate load at the failure, at the fracture of the member, that load it is called as the crushing load or crushing or compressive load, it is sometimes also called. It has been also experienced that sometimes a compression member does not fail entirely by crushing. Many of the times the compression member may not be fail entirely by crushing or by compression. It may fail by bending, and bending, we know that bending, it is a buckling. This happens in the case of long column. So mainly when we talk about the long column, entirely that column may not fail by crushing. Okay, short column may fail by crushing entire, but in the long column it may fail by crushing, or it can be failed by buckling or bending. So it has been observed that all the short column fails due to crushing, but if long column is subjected to compressive load, it is subjected to compressive stresses. Okay, so mainly we are only discussing on this in this unit, that is a compression member, column and strut. It's subjected to compressive loads, and because of that, it gives the induces the compressive stresses into the member. So if the load is gradually increased, the column is reach a stage when it starts buckling. Yes, if the load is gradually increased, the column is reach a stage when it starts a buckling. Okay, the load at which column just buckles, so means the load, it is a that load when column just starts to buckle, to bend, that type of the load it is called as a buckling load. Okay, when column starts bending, that type of load it is called as the bending load, or it is also called as buckling load. And for the long column, the value of buckling load is less than crushing load. So in the for the long column, value of buckling load is less than the crushing load. Next, crushing load. Now, what is meant by crushing load? The load at which members fails by crushing only. Crushing means there is a compression. Crushing means compression. The load at which members fails by crushing only, that it is called as a crushing load. And slenderness ratio. So what is the slenderness? Again, new term is there. You try to remember this and try to understand. Slenderness ratio, symbolically it is represented by lambda, and it is a ratio of unsupported length of the column or effective length of the column between the two end supports to minimum radius of gyration of the cross section end of the column. Okay, so this is the ratio of unsupported length or effective length to the minimum radius of gyration. Okay, means minimum radius of gyration, as we know, that is radius of gyration can be determined by I minimum divided by A under root. I minimum is, I is the moment of inertia, means actually suppose the two-dimensional figure is there. At that time there are moment of inertia about x axis normally, we determine, and about IY also, means on along the YY direction also we determine the moment of inertia. So minimum value we have to take from these two, and for the calculation of radius of gyration. So cross sectional area is already knows. If you take the under root, you will get the radius of gyration. So where I is equal moment of inertia and capital A is the cross sectional area. So you remember, slenderness ratio is the ratio of unsupported length or effective length divided by radius of gyration K. After that, buckling factor, it is the ratio between the equivalent length of column to the minimum radius of gyration. Okay, so buckling factor, buckling load, it is also called as a crippling load. The maximum limiting load at which the column tends to have lateral displacement or tends to buckle is called as a buckling load. So already you know that the load at which our column is buckle or bent, that load is called as a buckling load, as we seen. And also in other way, the maximum limiting load at which the column tends to have lateral displacement. Maximum load at which a column which bend in the lateral direction, or we can say the lateral displacement, or tends to buckle, right? So that it is called as a buckling load, or sometimes it also called as crippling load or critical load. So there are various names are there for the buckling load. It is also called crippling load or critical load or uh, buckling load. The buckling takes place about the axis having radius of gyration least, having least radius of gyration. So this statement is important. Buckling takes place about the axis having very less or very least radius of gyration. Means if the radius of gyration is least, automatically your moment of inertia is less value or least value of moment of inertia. So this is the criteria, or this is one of the parameter for the buckling. Safe load, after that, it is the load to which column is actually subjected to and is well below the buckling load. Okay, means it is obtained by dividing the buckling load by a suitable factor of safety. Okay, very suppose if you want to determine the safe load, so this safe load is below the value of buckling load and is obtained by, so we have to design our member or compression member for the safe load, because our structure should be safe. And if you have to design for the safer type of the structure, at that time this safe load we have to determine, and that safe load is determined by taking the value of buckling load, that is the ultimate crushing or maximum limiting load at which the beam is bent or try to bend or buckle. So that and also factor of safety, so sufficient factor of safety you have to take for determination of the safe load. Okay, and that value of the safe load is determined by taking the ratio of buckling load to the factor of safety. So this formula is important for determining the safe load, that is a buckling load divided by the factor of safety, right? So means, and definitely this safe load is always below the value of buckling load. Means buckling load is greater value and safe load is lesser value than the buckling load. Then and then we can say the load is safe or it is safe for the design. So I hope this theoretical part and these important terms related to the axial compression member, basically two members, that is a column and strut, we are discussing. So I hope you understood these terms. Definitely it is helpful for the coming topics, and whenever we are analysis of the compression member, and for solving the analysis for the different compression members. So these terms you try to remember, and also these formulas, whatever we have seen about the radius of gyration, crushing load, buckling load, and safe load also. Thank you very much.